Hello, it's Dumplet here. Here's an item on geometry. Given this figure on the left, such that I is the incenter of triangle ABC, angle ACB equals 90 degrees, find the measure of angle MCN. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, some of you guys may have encountered this item before, and this is a very common setup because you see two things immediately, and we have to focus on two particular quadrilaterals. So the first quadrilateral BCQN, and the other quadrilateral AMPC. Now we can do the following. We can try to observe here because we have a lot of right angles, and whenever we have right angles, chances are there's going to be a cyclic quadrilateral. Okay, now I'm gonna put angle QCB over here as a right angle since we know that angle ACB is given to be right, and then take a look at these three other right angles here as those are per the given figure. So the blue quadrilateral BCQN, since angle QCB and angle QNB are both 90 degrees, the opposite angles add up to 180, and therefore we can conclude that BCQN is cyclic. Now on the other hand, we can do the same for quadrilateral AMPC since angle ACP here is the same as angle QCB, which is going to be right as well, and we have AMP, which is given to be right. So angle AMP and angle ACP are both right, and these two opposite angles add up to 180 degrees. So the red quadrilateral AMPC is also a cyclic quadrilateral. So we can conclude two statements here. So that points CQ and B are concyclic and ACPM are also concyclic. Now this can have nice relations because from these two quadrilaterals being concyclic, we can observe the following. So let's focus on quadrilateral CQNB first. And we can notice that this angle QCN, label this angle QCN, should equal angle QBN because the quadrilateral is cyclic. So these two, if I draw the circumcircle of quadrilateral C and QB, these two would be intersecting the same arc. So they should be equal angles. Now what's nice about this is that angle NBQ, it's 1/2 of angle B. Now why 1/2 of angle B? Because BQ passes through the incenter I, and the incenter I, we know it's the intersection of the three angle bisectors. Well, in this case, it's the intersection of AP and BQ, so we can conclude that in fact BQ and AP over here are angle bisectors. So since we have angle bisectors here, we know that this angle is the same as 1/2 angle ABC. So 1/2 angle ABC. So since this is equal to angle, so 1/2 angle ABC, we know that this angle is also equal to 1/2 of angle ABC. Now, let's focus on the red quadrilateral, the red cyclic quadrilateral, ACPM. Now, with the same logic, I can conclude that this angle MCP, should be the same as angle MAP over here. Because if I draw the circumcircle of quadrilateral ACPM, well, these two inscribed angles would be intercepting the same arc. So then again, AP, as I've mentioned a while ago, it contains I, so AP must be an angle bisector. So we know that this red angle should be 1/2 of angle A, so angle BAC. Whoops, sorry, 1/2 of angle BAC. So since this equals this one, this red angle below, we know that this angle over here is going to be equal to 1/2 of the angle BAC as well. So if I want to get this angle in the middle, angle MCN, all I have to do is the following. Take 90 degrees because the entire angle ACB is given to be 90. So you have the 90 over here, minus the two angles over here. So minus 1/2 angle ABC and 1/2 angle BAC, and we can factor the 1/2 and we can get this. Now what's nice about this? Angle BAC plus angle ABC. If you go back, it's half of angle A and half of angle B. So angle BAC plus angle ABC essentially is angle A plus angle B of triangle ABC. And we know that triangle ABC here is right. And C, it has a right angle here at C. Therefore, angle A plus angle B over here, this is just actually equal to 90 degrees. So it's very nice that we have the angle MCN. We have angle MCN equal to 90 minus 1/2 of this, which is equal to 90 degrees. So in essence, we're just subtracting 45 degrees. So 90 minus 45 degrees, and this would give us that angle MCN, or the missing angle in the given, is equal to 45 degrees. And this is our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!